Hi guys, your lesson today is called functions. And this is something you're going to hear a lot of and use a lot of. Functions are a relationship between input and output, or x and y, another name for x and y. In a function, there's exactly one output for each input. That means you can only have the x happen once. Okay, I'm going to say that again. The x can happen only once, each x only once, but the y can happen more than once. So a function is a relationship with each element of the domain, the x, is paired with exactly one element of the range. So like there's only each element of the domain has one element of the range. The graph here with the squiggly line, that's also a function. Let's go on down. You're going to be determining whether each relation is a function. What you look for is, does the x values only occur once? There's 1, 4, 1, 3, 1, 0, 1, negative 2. So this is yes, it's a function. Here's your domain, your x. Is there an x that happens more than once? And yeah, there's 2 1s. So no, this is not a function. And then look at this one. Look at your x's. We have a 2, a 3, another 3, and another 2. So we have 2 of them that happen twice. So no, it is not a function. Don't look at the y's. You're only looking at the x's. Here's another one. Determine if each of the equations represent a function. Well, when you're looking at an equation, all you're going to have is an x value. There is no y. So no, it's not a function. When you look at these, if you don't see a y, it's not a function. This one down here has 4x equals y plus 8. There is a y, and there is an x. So yes, this is a function. They can be paired up. Now, there's another situation, though. If you saw this equation, y equals anything like negative 2, this is a function. This actually is a function. But you can never have it say x equals and only be 1x. That's never a function. So if it ever says like x equals 3, that's a no, not a function. You have to have a y in there somewhere. It can be a y without an x or an x and a y together. Another way is to make a table of those values and plot them, see how they line up. All right, here's the great way to tell if an equation is a function, is use the vertical line test. You know what a vertical line is. You just draw a straight line across a graph. If that line intersects the graph line in more than one spot, it's not a function. If this only intersects in one spot, so yes, it's a function. We draw a vertical line, and we're intersecting 2 times. So no, not a function. I'm going to draw a vertical line here. What if I draw it right on the y-axis? This hollow circle means that point is not included. A filled-in circle means the point's included. So would I intersect in 2 spots if it went down the y-axis? No. So yes, this is a function. I can't intersect twice anywhere I draw a straight line. Let's go on and practice looking at these. Looking at our table, this is yes, a function. These are all functions, but it's going to show you different situations. This is a function because all your domains happen only once. This is what this same table and mapping looks like as an equation. F of x, again, is another name for y. And you have your x or your y and an x, so this is a function. And then this one's a function. This is actually the graph of a parabola, but it is still a function. Let's go on to the next. So you're going to be looking at different situations where you have to determine if it's a function. And does every x have exactly one pair of the range? Does any x happen twice? No, it doesn't. So yes, this is a function. here, we look at our x values. We have 2. No, not a function. Look at our x's. We have a 2, and then a 1, a 5, and another positive 2. So no, not a function. Here we have y, we have an x, yes. You say that makes a function. You can do a vertical line test. If I go down the y-axis, I cross 2 points. No, not a function. Vertical line test. Anywhere I draw a straight line, I will hit 2 points. Yes, that's a function. But again, anywhere I draw a vertical line, I'm only going to hit that once. So yes, it's a function. In this case, I'm going to hit twice, here and here. So no, not a function. Alright, the last thing in this lesson is called function notation. It's a different way of writing an equation. So when you see y equals 3x minus 8, function notation, you're going to substitute the y for f of x. This is the same thing as y. It's just another way of writing f of x. It means exactly the same, those two. So the problems you're going to see, it's going to give you a function, f of x equals 2x minus 3, and you're going to find each value. So for example, when x is 1, when they plug in something in that parentheses, they're replacing x, because that's what's in the parentheses. Right here, there's an x there, and they're putting a 1 in place of it. So you're going to take this equation, 2x minus 3, and you're going to plug the 1 in it. You're going to do 2 times 1 minus 3. 2 times 1 is 2, 2 minus 3. The value of this is negative 1. We'll do the same thing now. We're going to put a negative 2 in place of x. So it's going to be 2 times negative 2 minus 3. That makes negative 4 minus 3. Negative 7 is the answer to this one. Now this has a little extra. First we're going to put the 5 in place of this function. Then we'll put a 6 minus out in front. So we've got 6 minus 2 times 5 minus 3. Let me work that out. Negative 2 times 5 is a negative 10 minus 3 with 6 in front. 6 minus 10, negative 4 minus 3. This also makes negative 7. Then we have 2 of them to do. So we're going to do negative 1 first. So 2 times negative 1 minus 3 plus 2 times 2 minus 3. We'll put it in 2 times. Negative 2 minus 3 plus 4 minus 3. Negative 2, negative 3, negative 5 plus 1, because 4 minus 3 is 1. Negative 5 plus 1 is negative 4. It's just taking turns plugging in whatever is in the x spot into that equation. Now, if we'll get into more of what nonlinear functions are later on, but it's simply if the exponent is greater than 1, the line it forms on a graph is not a straight line. So it's nonlinear, but it's still a function. So, but still, this works the same way. You'll plug in 4 for t. So this would be solved as 2 times 4 cubed. And work that one out. Negative 5, same thing. It'd be 2 times negative 5 cubed. And we work that out. And so these are different, just a different way to look at it, but with an exponent, it just means it's going to form a straight line. Other times you're going to see it say maybe g of x instead of f of x. It's still y. It's still another name for y. And so we're going to have different values, different functions to use. And which one you use depends on what it's asking for. Number 11 is asking for f, so you're going to use this equation on this problem. Number 14 is asking for g, so you're going to use that equation. Depends on which one it's asking for. I'm going to go over here and work out, we're not going to have time to work out all of these. I'm going to try to do maybe number 13. So I'm going to use the 6x plus 7. 6x plus 7 because it's f. It's a function of f. So I'm going to plug in r minus 2 wherever x is. So it's going to be 6 times r minus 2 plus 7. So I took the r minus 2 and I plugged it in for x. Now I'm going to solve it. Distributive property makes 6r minus 12 plus 7. Then I can put down my plus 12 and 7, my negative 12 and plus 7. So the final answer is 6r minus 5. And that's as far as we can go with that one. I'm going to take number 16 now, g of the negative 4 out, and we're going to solve it. Give myself number 16, I'll write that down again, is g of negative 4t. So I have to use this equation. So it's going to be x squared minus 4. So the negative 4t goes in place of x. So it's going to be negative 4t squared minus 4. When we square this, we're going to get a positive 16t squared minus 4. And that's as far as we can take that one. Because those are not like terms, so we cannot put them together. And that's going to wrap it up. I'm going to stop here because we've used a lot of time.